This screencast serves as a review for chemical reactions. This should be a topic that was covered in 8th grade. So at the end, you should be able to balance chemical equations and to write formula equations from word equations. Okay, chemical equations or reactions are recipes for making compounds. So when we write equations like this, what we really are writing is something that represents a real chemical reaction that's going to be happening, or that could happen. So here we have two hydrogens reacting with one oxygen molecule to create or produce two water molecules. We need to balance chemical reactions so that they have the same number and type of atoms on both sides of the reaction. So if we look at this reaction again, we notice that on the reactant side, that is this side of the equation, I have 4 hydrogens. 2 hydrogen molecules. Each molecule has 2 hydrogen atoms, so it's a total of 4 hydrogen atoms. And I also, on the reactant side, have 1 oxygen molecule. Each molecule has 2 oxygen atoms. If I look at the product side, that's this side of the equation, I have 2 water molecules. Each water molecule has 2 hydrogens, so I have a total of 4 hydrogen atoms. Each water molecule has 1 oxygen atoms, but I have 2 molecules, so I have 2 oxygen atoms. And that's really what balancing chemical equations is about. What law do we have to follow that equations have to be balanced? Well, it is the law of conservation of mass. This law states, this is something that you should have in your notes, this law states that matter is neither created nor destroyed in ordinary chemical reactions. So the types and numbers of atoms on the reactant side have to equal the type and the number of atoms on the product side. When we balance equations, we have to be careful that we only change the coefficients. That's the number in front of the chemical compound. We only change those so that we get equal numbers of each type of atom on both sides of the equation. Do not change the subscripts. By changing the subscript, you're actually going to change the compound. So let's look at an example. We have phosphorus reacting with oxygen to produce diphosphorus pentoxide. Underneath the yield sign, I'm going to write what reactants are present in my reaction. I have phosphorus and I have oxygen as my elements. On the product side, how many atoms of phosphoruses do I have? Well, I have 1. I have 2 oxygen atoms. On the product side, I have 2 phosphoruses and 5 oxygen atoms. Okay, well, these have to equal each other, and we could start with the phosphorus. I see that they're not equal on the product and the reactant side. To do that, I'm going to change this coefficient in front of the phosphorus to a 2. That makes my total atoms of phosphorus change to a 2. So now my phosphorus is balanced, but my oxygen isn't. All right, well, I have a 2 and a 5. Well, there's no multiple of 2 that's going to equal 5, so I'm probably going to have to change it to a common multiple, which would be 10. So I'm going to change this coefficient to a 5, which would then give me these 10. And then I'm going to change this to a 2, which would then give me 10 oxygens. But when I change this, I also change my phosphorus number. So I have to update that as well. Now I've changed that to a 4. Oh. Well, now my phosphoruses aren't balanced. So I have to go back over here and redo this coefficient to a 4 so that now my phosphorus are balanced on the reactant side and the product side, and double checking my oxygens are as well. That's my process for balancing a chemical equation. Let's look at another example. Here we've got calcium carbonate reacting with phosphoric acid to produce carbonic acid, and calcium phosphate. I'm just going to identify the elements that are present in my reaction. I have calcium, I have carbon, I have oxygen, I have hydrogen, and I have phosphorus. All right, just counting first, I have 1 calcium on the reactant side. I have 1 carbon on the reactant side. I have these 3 oxygens and these 4 oxygens, which make 7. For hydrogens, I have 3, and for phosphorus, I have 1. Looking at my product side, I have 2 hydrogens, I have 3 calciums, I have 1 carbon, 3 oxygens here, plus these 8 give me 3 and 8 give me 11, and for the phosphorus I have 2. Okay. Well, starting at my first element, I notice calcium's not balanced between them, so I'm going to add a coefficient of a 3 in front of this compound to bring my calciums more in line. So that 3 changes my calcium to 3, changes my carbon to 3, changes my oxygen to 9, plus these 4, or 13. Not affected my hydrogen, did not affect my phosphorus. So now my calcium's balanced, but my carbon isn't. The only component here in the product side that has carbon is the first one. I'm going to put a 3 in front of it. So by putting a 3, I change my hydrogens. So now I have 6 hydrogens. I have 3 carbons. For oxygens, I have 3 times 3 is 9, plus these 8 gives me 17. Huh. Okay. Now, oxygens look a little out of hand, so I think what I typically leave oxygen to the end. So let's look at this phosphorus first. Phosphorus isn't balanced yet. Okay, so, if I put a 2 in front of here, I bring my phosphoruses back. But let's look, now that changes my hydrogens, changes my hydrogen to 6, changes my phosphorus to 2, and then also changes my oxygens. I have 8 here and 9. Oh look, that changes my oxygen to 17. Now looking at these numbers, my equation is balanced. Looking at another example, again, identify my elements. I have carbon, I have hydrogen, and I have oxygen. My carbon, I have 17 on my reactant side, 16 hydrogens, and 2 oxygens. On my product side, 1 carbon, these 2 oxygens plus that one gives me 3, and I have 2 hydrogens. All right, well, carbon's not balanced, so if I put a 7 here, my carbons would be balanced. Now I have 7 times 2, 14 oxygens, plus that 1 gives me 15 oxygens. Again, I leave oxygen to the end. So let's look at hydrogen. 16 on this side, 2 on this side. If I put an 8 in front of here, that changes my hydrogen to 16. Changes my oxygen to these 8, plus 7 times 2 is 14. 8 and 14 is 22. Carbon's balanced, hydrogen's balanced. If I change my oxygen to 11, that will make that 22. And that's balanced.